This is section 11.5, sums of series, and our goal here is to be able to add up an arithmetic or a geometric series without actually having to add every individual term, so we're looking for a shortcut. Just a quick note about notation, we're going to use S sub n to stand for the sum of the first n terms in a series. So let's take this series that we have here. S sub 4 would be the sum of the first 4 terms. So that would be 1 plus 3 plus 5 plus 7. And when we say S sub 4, we actually want to find the value of the sum, so we want to add those all up and get 16. Similarly, you could say S sub 2, that's just the sum of the first 2 terms, which is 4. So this is just a continuation of the exploration of arithmetic series that we did in class. We were looking for a shortcut to add these up, and we noticed that if you take the first term and the last term, they add up to 34. And if you take the second and the second to the last, they also add up to the same thing. And you can continue that pattern. 11 and 23 will add up to 34, and 15 and 19 will add up to 34. So this then is a shortcut to finding the total value of this series. There are 4 pairs, and each pair has a sum of 34. So we do 34 times 4 and get 146 is the value of this if you were to add it all up. You can check that on your calculator. How many pairs are there? Well, in this case, there were 8 total terms. And since there are 8 terms, there are half as many pairs, so there were 4 pairs here, and in general, if you have n terms, you have n over 2 pairs. What's the value of each pair? Well, to find the value of the first pair, we took the first term and added it to the last term. And in general, the value of each pair is going to be the sum of the first term and the last term. If there are n terms in the sequence, t sub n stands for the last term. So we can write a formula. The sum of the first n terms of an arithmetic sequence is equal to the number of pairs, n over 2, times the value of each pair, which is the first term plus the last term. We have an alternate way we can write this formula. You can write it as n times the first term plus the last term and the entire thing divided by 2, and that's what you'll see in your book. So just for your notes, here's the formula we established for an arithmetic series. And even though we haven't explored it, this formula is how you would add up the terms of a geometric series. The sum of the first n terms is equal to the first term times 1 minus the common ratio to the n power, all over 1 minus the common ratio. The placement of the parentheses there is really important. And also notice that you don't need the last term of a geometric series to add them all up. You just need the first term, the common ratio, and the number of terms that you're adding. I want to focus for a second on the little thing to the right that says r is not allowed to be 1. That's just a restriction on the common ratio, because if r were 1 and you were to stick that in the denominator there, you'd get 1 minus 1, which is 0, and that would result in division by 0. So you don't have to write down r doesn't equal 1 every time you write down this formula, but it's an important thing to note. So now we're going to actually use the formula, and we'll start this by taking it out of sigma notation and just writing it out as a series. So the first number we put in is a 1. We have 2 times 1 minus 1 plus 2 times 2 minus 1. Writing out in expanded form helps us to tell whether the series is arithmetic or geometric, so we know which formula to use. And we'll end with the last couple terms, 2 times 23 minus 1 plus 2 times 24 minus 1. And now we'll simplify to write the series in expanded form. You can tell that this series is arithmetic because you add 2 to get to the next term of the series. So we'll use the formula for the sum of an arithmetic series to add this all up. And that is the sum of the first n terms is equal to the number of terms times the first term plus the last term, all divided by 2. We started by plugging in a 1, so t sub 1 is 1. And then we plugged in numbers all the way up to 24, which means 47 must be the 24th term of this series. So we know that's t sub 24, which means we're finding the sum of the first 24 terms. So n must be 24. S sub 24 is equal to 24, the number of terms, times the first term plus the last term, all divided by 2. And now it's just a matter of simplifying and using your calculator. This is a very similar problem, it just doesn't start with sigma notation. They give us the first term and the last term. Notice that this must be arithmetic because you're subtracting 2 to get to the next term every time. We'll think of that as adding -2. So this is the formula we're going to use. The sum of the first n terms is equal to the number of terms times the first plus the last, all divided by 2. We know that 50 is the first term, but we don't know which term of the series 10 is. That's going to give us n. Where in the list is 10? We're going to solve for that by writing a formula that will allow us to solve for n, and that's the formula for each term of an arithmetic sequence. The nth term is equal to the first term plus the common difference times n minus 1. And then 10 is the term we're wondering about, so we'll plug that in for t sub n, and now you'll notice that our only variable left is n, which is what we're looking for. Subtract 50 from both sides, so we have that -40 is equal to -2 times n minus 1. Lots of good ways to solve or simplify this. I'm going to divide both sides by -2. So I get that 20 is equal to n minus 1, which means that n is 21 and 10 is the 21st term in the series. So this means we're adding up 21 total terms. So the sum of the first 21 terms is equal to 21 times the first term plus the last term, all divided by 2. And now it's just a matter of simplifying. 21 times 60 divided by 2, which is the same as 21 times 30, which is 630. All right, another one that starts with sigma notation, so we'll want to write that out the long way first. We'll start with 30 minus 10 plus 30 minus 11, and we'll take that all the way up to 30 minus 20. I want you to notice that there won't be 20 terms here because we didn't start with 1, we started with 10. And we'll simplify this so we can see the terms very clearly. Here I'd like you to pause the video and try this problem on your own. All right, so we'll be using the formula for the sum of an arithmetic series. The sum of the first n terms is equal to the number of terms times the first term plus the last term, all divided by 2. And the question is, how many terms are we adding up? Since it starts at 10 and ends at 20, you might think that it's 10 terms, but in fact, if we count it out, you'll see that it's not. Since it starts at 10, we plug in 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that means there are 11 terms of the series we're adding up, and the way to find that is always to do the number on the top of the sigma minus the number on the bottom plus 1. 20 minus 10 plus 1 is 11 terms that we're adding up. So that must be 11 times 30 divided by 2, which gives us that we are adding up 330 divided by 2, which is 165. Just like last time, since this is in sigma notation, we'll want to write it out in expanded form to find its sum. The way that you use parentheses when you're writing this out is going to be really important, because a negative to an odd power is negative, but a negative to an even power is positive. So we want to make sure that the negative is included inside parentheses. This is going to go all the way up from -1/2 to the first to -1/2 to the 10th. You can simplify these by hand, or if you need to, use your calculator. -1/2 to the first is -1/2. -1/2 to the second is +1/4. -1/2 to the third is -1/8. And keep going. -1/2 to the 10th, because it's an even power, we know that that will be positive, and 2 to the second power is 1024. Before we can add all this up, we need to determine, is this series arithmetic or geometric? Notice that to get from one term to the next, you're multiplying by -1/2, which indicates that this is a geometric series. One clue that will often let you know that a series is geometric is if there is a variable in the exponent. You are generally looking at a geometric series. Now that we know it's geometric, we can apply the proper formula. The sum of the first n terms of a geometric is equal to the first term times 1 minus the common ratio. Don't do this. That n is in the wrong spot. you instead want to make sure that the n is inside that pair of parentheses. So 1 minus the common ratio to the nth power all over 1 minus the common ratio. Notice that we don't even need the last term. We just need the first term, which is negative 1/2, times 1 minus parentheses here because we're taking the common ratio of negative 1/2 to the nth power, all divided by 1 minus the common ratio. Remember that a negative number taken to an even power is going to give you something positive, so this will be equivalent to negative 1/2 times 1 minus 1 over 1024, because that's 2 to the 10th. That's a coincidence that that's the same as the last term. And then a negative being subtracted gives you a positive, so that's what we're simplifying. I'll pull out my calculator to simplify this. We need parentheses for the whole numerator, then parentheses for negative 1/2, another pair of parentheses for 1 minus 1 over 1024, which we'll also put in its own set of parentheses. Close all of those, and then divide by, oh, that means I put one too many parentheses. If I choose go to, it'll show me where. Let's get rid of some parentheses, so that's the numerator. And then I can divide that whole thing by the denominator, which is 1 plus 1/2. That gives me an ugly decimal value, but remember that the math key and then the first command frac will put that into nice fraction form for you. Another one in sigma notation, you can guess that this is probably geometric because there's a variable in the exponent. But let's write out some terms. 640 times negative 3/2 to the first, then to the second, then to the third, and we'll go all the way up to the 9th power. And let's simplify each of these on the calculator. 640 times negative 3 over 2 to the first. And then I can hit second entry to get that back, and then just add a to the second power. I can hit second entry again, and go back and change that 2 to a 3. And I can do that again and go back and change that 3 to a 9. So I don't have to type this over and over and over. So an expanded form our series looks like this. Remember from the earlier sections that to find the common ratio, you can take any term and divide by the one before it. That'll work for any geometric series. So 1440 over 960 should be the same as negative 2160 over 1440, and we'll do both of those on our calculator just to make sure. So you can tell that the common ratio is negative 1.5, which is the same as negative 3/2. That thing that's being repeated is generally your common ratio. You can use the formula for the sum of a geometric series, which is the first term times 1 minus the common ratio to the nth power, all over 1 minus the common ratio. In this case, the first term is negative 960, and then we have 1 minus negative 3 over 2 to the 9th power, because we're adding up 9 terms, all over 1 minus negative 3 over 2. To simplify this, I would put it into your calculator one piece at a time. Remember that a negative to an odd power is always going to be negative. And because of that negative outside of it, then you would get a positive there. So here's what you're simplifying. Again, that bottom, a negative, negative is a positive. So I'm going to put that into my calculator one piece at a time. I'm going to start with the very inside, negative 3/2 to the 9th. Then I'm going to take that answer and add 1 to it. Then I'll multiply by negative 960. And then I'll divide that whole thing by, in parentheses, 1 plus 3 over 2. So we have a decimal answer, and you can ask it to turn it into a fraction for you. Unfortunately, this one, it doesn't want to, so we'll do it manually. So we can either write this as negative 15,146 and a fourth, or you can take the whole number, multiply it by the denominator, and add it to the numerator to turn it into a mixed number. So that's what I'm doing on the calculator there. So I would have negative 60,585, all divided by 4. That's a mixed number version of that answer. All right, and now we're going to find the sum of the first 10 powers of 5. So 5 to the first plus 5 to the second. We'll add those up all the way up to 5 to the 10th. And in expanded form, that looks like this. 5 plus 25 plus 125. You can tell by taking a look at this series that it's geometric because you would multiply by 5 to get from one term to the next. Because it's geometric, the nice thing is we don't actually have to find the value of 5 to the 10th. The only things we need for the formula are the first term and the common ratio, and then the number of terms that you're adding up. So we'll use that formula. The sum of the first n terms, which is 10, is equal to the first term plus 1 minus the common ratio to the nth power, all over 1 minus the common ratio. And you can enter all that into your calculator to solve. 5 to the 10th, do 1 minus that, multiply it by 5, and then divide by negative 4. All right, so it looks like if we were to add all those up, no surprises there since the numbers get pretty big at the end, our answer is 12,207,030.